Hi all. We'll move ahead with next topic, that is POSIX 0.1b timers. Here, so previously just we studied about yeah, 12 timers. Okay, so for that POSIX created a new timers only, that is in standard that they created five functions. Okay, so those are from we studied. Okay, so first one is timer create, then second timer set, okay, and then get time, okay, then get overrun, delete. Okay, so you have five functions. Okay, these are the syntax for that. Okay, so first one is timer create API is used to dynamically create a timer and runs its handler. So whatever handler will give it, so that handler it will run it. Okay, and dynamically you can create the timer. So here clock argument specifies which clock the new timer should be based on. So whatever clock variable will give, so whichever based on that thing it will mention it. The value may be, so it may be a clock underscore real time, okay, for the creating of real time clock, or already we studied as a virtual also, so that also will be there. So by studying here whatever we studied, so for that also here whatever will be there, same thing like virtual also. So along with this it takes one more argument, that is a spec. Okay, so here this is a one structure variable. Okay, so it's defined as a structure, it contains three things. Okay, so seg event is nothing but it contains three things: seg notify, okay, seg event signal, seg value. So three fields it has. Okay, there is nothing but signal number to be raised at the timer expired. So whenever timer will expire, which kind of signal it has to raise it, that it contains. And valid, this field is valid. Okay, so whenever seg ev underscore notify field is set to seg ev underscore signal. Okay, so means whenever you want to notify it, so in this actually we have three fields, that is notify, okay, seg number, then value. Okay, so this second field seg number is valid only whenever seg notify is set. Okay, so that time only if you want to get some signals, that time we'll set it, then corresponding signal number will give, then corresponding value also you can pass it. Okay, so here again value also it may be some kind of you can send exactly integer value, or you can send as a sigval pointer, one pointer. So that pointer contains the some address of signal handler wherever you want to specify it. Okay, so those things will be there. Okay. Then okay, so just will see, so these things how we can use it. Okay, so then get overrun. Okay, so this API returns the number of signals generated by a timer, okay, but was not lost. Okay, so it means whenever it's generated, the handler will give it. So whenever you are giving this one overrun, okay, so number of signals generated by this timer, okay, and those are not lost. Especially timer signals are not queued. Okay, so normally by the kernel if they have raised but not being handled by their target processes. Okay, so that time we will use this thing. And next so here we see one example. Okay, so what we are doing in this one is just we're mentioning when actually absolute for absolute time. Okay, so that is timer has to go off at particular time, that is 10:27 a.m. April 20th, okay, 1996. Okay, so those values we are setting it here. Okay, so this is 20th April 10:27 a.m. Okay, 1996. Okay, so whenever this time will come, so that time it has to give the signal. So just we are mentioning the exact time where when it has to run it. This is absolute time we are giving it. So So what we are doing is first thing. Okay, so here just we are mentioning that is we're setting up the call me function, okay, as a signal handler for this signal user one signal. Okay, so user one signal, that is here. Okay, so whatever we have sync user one signal, so user related first signal, you have two kinds of user signal, signal user one and two. So whenever first signal will come, so that time this handler has to execute it. Okay, so that handler we are giving it, so in that just we are putting the some values. Okay, so then what we're doing is we're creating a timer based on the system real clock. Okay, so based on real clock we're creating a timer, that is here we're mentioning as a timer create. So based on real time we're creating it. So and for that we're passing these values. Okay, that's the sigx value and this is the handler. So sigx values are nothing but here, from here we mentioned. Okay, so notify, okay, signal number, okay, and value for that. So signal notify we're setting as a get signal. Okay, so you want to get the signal, you want to notify it whenever it will get off. Okay, so timer will get off, that time you want to receive a signal. Okay, so which signal, that is a user signal you want to receive it, user signal first one. Okay, so for that corresponding signal handler also we have given here. Okay, so this is the signal handler call me, this signal handler we have given it. So sig action whenever we are performing here, that is this action for this signal, this is the action part we are giving it. Okay, that is flag we are setting it, and empty set, that is for the masking purpose. Okay, so we are making others the all masking bits as a empty. So flag we are setting as a signal info, and this is a command handler sorry, this is the handler for the signal we are giving it. So here just what we are doing is just we are setting the real clock. Okay, so then the timer should rise. Okay, so this timer should rise whenever signal one, user signal one is expired, and the timer's specific data should be sent along with the signal timer underscore tag. Okay, so whenever this uh, expires, that time it has to send it, and here it has to send the value. Okay, so value here we are mentioning this value. Okay, so this value 12 we are mentioning it. So okay, what is that 12, we'll discuss it whenever we'll see the output, will come on. Okay, uh, then the timer handler returns by timer underscore create. Okay, so timer handler, this is there, whatever it will return by timer underscore create handler, so which is set in this variable. Okay, so it will return one handler in this one. So previous handler whatever was there, that it will return in t underscore id, here it will return it. So after this what we are doing is just we are setting that timer when it has to go off. Okay, that is nothing but we are setting as a, this is the date, particular date and particular time we are setting it. So that is our 10, okay, minutes 27, okay, seconds. So here we are not mentioning second in comments, so that is second also we are writing as 30, month 3. Okay, so let's say April month, actually it has to come as a 4. Okay, so fourth month. Okay, then year 96, so this is year 96, then day 20, so April 20th. So day, so particular exactly date and time when you want to set the timer, that we have mentioned. So that is there in do underscore time variable. Okay, so this is the do underscore time variable structure tm, in that we're defining it. Okay, so so this one we have to convert into absolute time. Okay, so this is nothing but with respect to user defined how you want that he given, but for the system absolute time should be there. Okay, so what we will do is we'll call a mk time. There's nothing but make a time. This this parameter we're passing it. So whatever structure we received, in this structure we're passing it. So this whenever we'll receive it, so it will take the absolute value. Okay, so absolute value will take it here. Then we are setting as a every 15 second this has to repeat. Okay, so this is when it has to start, then every 15 second it has to repeat it. Okay, that we are mentioning it. Okay, then after all this one then timer underscore set time. Okay, so timer underscore set time function is called to start the timer running. Okay, so now here we are calling and we are saying that we have to start the timer running now. Okay, so these are the values we defined. So that value we're passing it here, so it will start running it. Okay, so then program will wait, okay, for a timer to expire. Said that is nothing but certain 30 seconds like that. So here we are pausing it, so this will wait for the timer to expire twice. Okay, so twice we are been doing it here. This one is a two times we are running it in pause. So first time whenever timer will expire, so it will come out of this one pause. Okay, so again it will since this I value will be less than 2 second time after incrementing, so again it will go in pause. So again second time whenever timer will expire, that time we will wait it. So if we don't have twice, we'll wait it. After that what we are doing is just we are deleting it. So whatever we have created this timer, okay, so whatever these all things, so here, so whatever handler was running it here, okay, so this is the what after creating we are getting it. So this one here we are deleting it. Okay, so just we are giving here to delete it. So after that, if it is time error is coming, this process will not wait for that. Automatically it will get deleted. Okay, so what output we will get is nothing but we will get the message. Okay, that is nothing but first time it will get the message say here this one. Okay, so that is the timer will go off at. Okay, so after that it will print the exact value. Okay, so what is that value is nothing but here it will print it, that is the whatever date and time is there. Okay, so this date and time it will print it. After that it will whatever we are doing is nothing but here actually we are pausing it. So system will generate the signal, so that signal corresponding command handler will be called. Okay, so that is something what here are coming here. Okay, so in command handler this will be called, so then it will display as a call me. So then it will display this signal. Okay, so that is a signal number, so whatever we are sent it signal value. So here actually we send the signal value, so whatever value you want to send it. So it may be used for some specific purpose, that is a maybe comparison we will do it, we will perform some task. Okay, otherwise whatever we sent it this value just we are printing it here. Okay, so here it will print as a call me. So after that 12 it will print, then signal number, so whatever signal number is there that it will print it. So here signal number, user signal number, whatever is there, this macro value it will print it. This macro value is actually 16, so it will print here there is a 16. Then time, so what time it came. Okay, so that time we are printing it. So whatever this is there, so this time it will print it. Okay, so that is first time. There's exactly you are given as 30 seconds, so whenever it will come as a this 10 27 30 second it will come, so that time it will expire. So second time again, so because this is running in for loop, so second time it will wait for pause again. Okay, so again timer will come, that is it will expire it, because we told us every 15 seconds this has to run. Here we given the instruction is every 15 seconds this has to run. So what it will do after 15 seconds again it will run it. So that time again this will call, so again the value will be same here, call me, then here it will come as a this value whatever we given, that is 12. Okay, so then signal number, then this user signal number, this is 16. Okay, then 16, then here value will be printed. So what time it's printing it this one. Okay, so this is whatever time we have in this command handler, whatever time we have in handler signal handler. Okay, so this signal handler here this time will be in the, so far this is second time, so that is 10 27 30 we have printed, then after 15 seconds, so that is nothing but 45 it will come. So it will display as a, it is a 10 for 27 45 second it will print it. So just we are doing for this one is for the twice. Okay, if you want to run it multiple times or infinite loop, if you want to keep it, so you can keep it. Okay, so that time automatically it will run for infinite time. Okay, so this is what POSIX.1 B timers.